Hello everybody and welcome to this lesson. The topic for today's discussion is estimating the demand function. First, let us see what forecast mean. Forecast is an estimate or a prediction of an event which will happen in the future. Forecast is an estimate or the prediction of an event which will happen in the near future or in the long run future. Thus, demand forecasting is an estimate of the future sales or a prediction of the future sales for the firm's product, or a prediction of the demand of the consumer towards the product of the firm. There are different types of forecasting, by the way: the marketing, production, finance, personnel, even the weather forecast, GDP forecast, and so on. Here is the importance of demand forecasting. Forecasting is the main components of managerial decision making at strategical, tactical, and operational. At all levels of managers, forecasting is important. Planning and scheduling production, plant capacity, and amount of resource required for the production is determined by demand forecasting. In general, planning, the main managerial functions of the management function, the first managerial function we can say is only possible through forecasting. We can only plan if we can conduct forecasting. And forecasting avoids or reduces, we can say, surplus and inadequate production. By the way, both have disadvantage for the organizations. And we can better manage our inventory levels through forecasting, or we can decrease the business risk that we face by underproduction, overproduction. So we can decrease that business risk, and ultimately we have smooth operations of the business by demand forecasting. We can also control quality and quantity through forecasting. And the last one is we can formulate the pricing strategies. There are, by the way, different pricing strategies. So we can formulate our pricing strategy based on the demand forecast. These are the steps that we follow while forecasting. The first step is specifying the objectives of the forecast. That means the types of forecast, whether it's demand forecasting, technological, or economical forecasting. And the next is the time horizon, whether it is short term or long term. As we forecast in the short term, the forecasting becomes better accuracy. The forecasting has better accuracy, and if the time is longer, so it is less accurate. And the data availability. That means whether we have secondary data, primary data. We have to know if we have adequate secondary data, reliable secondary data, and appropriate secondary data for our forecasting. So no need to go to the primary data. If we have no secondary data, so we can go to primary data. And the fourth one is choice of the methodology, whether it is qualitative or quantitative. We have generally two approaches, that's qualitative or quantitative. So based on our data, the availability of the data, so we can determine. If there are historical data, we can go to quantitative. If we have no data available, so we can go to qualitative method, And the last one is estimation and interpretation of the results. That means we have to describe the results. We have to give a meaning for the results. What does it mean? In doing demand forecasting, we have to consider the following points. The first one is the characteristics of the decision-making situations. The time horizon, the levels of the detail required, and the group versus the single items. Sometimes we have to estimate, we have to forecast in group, or sometimes we have to forecast in single items. Doing forecasting in group has better accuracy than forecasting for single items. And the second one is characteristics of forecasting demand, that is the cost of the methods. The cost of the method should be considered. it should be based on our capacity. The accuracy level the accuracy level provided by the method should be also considered, and the ease of application. If it is very difficult, and the next is the levels of demand forecasting. There are 3 levels of demand forecasting. The first one is organizational level or firm level or micro level, which is conducted in the organizations and majorly conducted by the management of the organizations. Specifically, we can take an example of Kombolcha Textile Factory. It is an organization, and the demand forecasting conducted in that factory, in Kombolcha Textile Factory, is micro level or firm level. And the second is industry level. The industry is formed by, or industry constitutes all the factories involved in manufacturing the same types of products. For example, the textile industry is a collection of textile factories in Ethiopia. Textile industry. That means industry level means it considers the whole factories, and it is conducted by the trade associations. Then it is availed to its members. So in our country context, we can consider as the agricultural industry, the textile industry, or the manufacturing industry, and so on. And the last one is the macro level, which is the aggregate levels of the industry levels that make up the country economy as a whole, For example, when we predict or forecast the demands of Ethiopia as a whole, or the national expenditure, or the aggregate demand and supplies of Ethiopia as a whole, it's termed as macro levels demand forecasting. And it is conducted majorly by National Institute, government agency, and it helps the government, because it is macro level, and it helps the government to determine volume of export and import and control of the price of the commodities in order to control the inflations of the country. These are the forecasting techniques. There are 3 major forecasting techniques: the qualitative models, the time series methods, and the causal methods. We will see each of them. The first one is qualitative models. It involves judgmental or subjective factors. Expert opinions, individual experience, and judgments are included here. And it is majorly used when there is no quantitative data, because it is believed that the quantitative data gives better predictions as the qualitative data, because the quantitative data is free from subjective bias. And it is used when we produce new product, because in the case of new product, we don't have any historical quantitative data. Under qualitative models, we use several techniques, specific techniques, that is Delphi methods. Here, several knowledgeable and experienced persons are asked to provide their subjective estimates of the demand. First, they need to have knowledgeable on that subject matter, and they need to have experience as well. And they are asked to provide their estimates. And when all that estimates are converging to some point when there is an agreement, so that becomes the estimations of the demand. The process is iterative process until the panel converges, or until the agreement reaches on a specific value or arrives at a consensus on the matter under consideration. This is what we call Delphi methods. And the other is, we can also conduct consumer interview or market studies or experiments. We can directly ask the potential buyers of the product, how much of a good they would buy at different prices. We can vary the prices, and we can ask the volume that they are going to buy with different prices and with alternative values for the demand determinants such as household income, price of related goods, and expected future price. We have to vary also. We have to include the income, the price. We have to vary the income of the household, the price of related goods, the other goods, that means substitute or complement goods, and expected future prices. But the problem for this method is selections of representative sample. By the way, sample should be representative of the population. By representative, we mean that the characteristics of the sample or the features of the sample should be matched with the population that they are drawn from. And there is response bias because individuals act differently in different situations. And the other is inability of the respondents to answer accurately. Sometimes the respondents may not be accurate on the questions. And the other method is market study or experiment. It is costly and difficult technique, actually. By making everything constant, by the way, this one is an assumption, except the price of goods, except we only vary the price of the goods by making other things constant. So we have to see the response of the consumers. We have to see the actions of the consumers by making other things constant. For example, income, price of related goods, expected future prices constant, and we make the price to vary, and we have to see the response of the consumers. We can conduct in shops or in stores of the company or in the laboratory. This is a time series or quantitative data. It is based on sequence of evenly spaced historical data. The data can be daily, monthly, weekly, quarterly, or yearly. And this technique is more accurate, and computers or different softwares can be incorporated to speed up the process. The historical data may have a trend characteristic, gradual upward or downward movement of the data over time, or seasonality pattern. It's a pattern of the demand fluctuation above or below the trend line that occurs every year, like this. And the cycles also the pattern that repeat itself after some durations of the time. And the random variation is, this can be caused by the chance or unusual situations. For example, it can be caused by the pandemic, it can be caused by the natural disasters. The demand may vary. Let us see one example of time series or quantitative data. These are the years, 1 to 10 years, and the television sets, the annual sales for the three products. The television sets, as you see, it is constant through all the years. The radios are increasing. It increases through 10, 300, 310, 320, and the compact disc, it has fluctuating sales, fluctuating. Actually, it increases, but it is fluctuating. Let us plot these tables on the XY axis to show the relationship between the years and the annual sales. The first one is the annual sales of the television. As we see from the previous table, it is constant sales through all the years, through all the 10 years. It is constant, so the graph can be drawn like this. It is a straight line, and the sales is 250. The sales appears to be constant over the time. This horizontal line could be described by the equation sales equals 250. Regardless of the time, it is constant. No matter what year, it is constant. And a good estimation for the 11 year is 250. A good estimation of the future sales. For example, if you want to estimate for the 11th year, it will be 250 because it is constant for the last 10 years. And the second graph is annual sales of radio, which increases 10 on yearly base. So sales appears to be increasing at a constant rate, that is 10. So the equation can be sales equals 290 plus 10 times year. 290 is the y-intercept. The y-intercept, that is, if the line is extended left to the vertical axis, if we extend this line, so it touches 290. It touches 290 at zero year. So it is the y-intercept. Best describes this relation between the sales and this time. A reasonable estimate of the radio sales in 11 years is 400. We just replace 11 here. So 11 times 10, 110. So when we add with 290, it becomes 400. And for the 12 year, we have just simply replace the year by 12. And we can get 410 because the trend shows every year there is an increment of the sales, that is by 10. And the last one is annual sales of the compact disc. As we have seen in the previous table, it is fluctuating, but there is a trend line that may not be perfectly accurate because of the variation of each year, but there is a trend line which shows an incremental trend, But CD compact disc sales do appear to have increasing over the past 10 years. If we had to forecast the future sales, we would probably pick a larger figure for each year because the trend line shows what it looks like over a duration of 10 years. And the next is moving average. Moving average is one of the time series or quantitative data methods. Here we have to use the averages. We have to use the average in order to forecast. First, we have to calculate the averages. For example, 3 years moving average, 4 years moving average, or 8 years, 6 years, 7 years moving average. When we are preparing moving average, we have to add the new values and we have to delete the oldest value and adding the new value in order to increase our accuracy. Moving average can smooth out the fluctuations because it is average, so we can smooth out the fluctuations in data while preserving the general pattern. But it preserves the general pattern. If it decreases, the moving average also decreases. If there is an increment trend, the moving average also an increment trend. Longer average results in more smoothing. If we take many data or several data for calculating the averages, it has more smoothing. It makes more smoothing. However, the problem in moving average is they do not yield the forecasting equation. It can't provide the forecasting equation, nor do they generate values of the ends of the data series. This is the problems of the moving average. For example, here, the 3 years moving average. In order to forecast the 8th year, so we have to take the 5th, the 6th, the 7th, the preceding 3 years. And we have to divide by 3. This is a formula to calculate the moving average. And the next is the weighted moving average. A weighted moving average allows some values to be emphasized by varying the weights. We have to give some weights, for example, for the recent data, and we have to give less weight for the former data. Weights can be used to put more emphasis on the recent period sometimes. Weights can be either percentage or real numbers. Let us see this example. Here is The shipment in tons of welded tube by aluminum producers are shown below. These are the years 1 to 11 years, and these are the shipments in tons. Graph the data and comment on the relationship. By the way, we have to put the year as x-axis and the ton as y-axis, and we have to put these pointers, this pair of pointers, and we have to see the relationship. We have to see the trend. And second one is compute the 3-year moving average, plot as a dotted line, and use it to forecast the shipments in 12 year, using 3-year moving average. Using the weight of 3 for the most recent data. By the way, here the most recent data is 19. And 2 for the next data is 18. And 1 is for the oldest, 14. In taking 3-year moving average, we have to take these three. So this one is the recent, and this one is the next recent, and this one is the oldest data. So using a weight of 3 for the most recent data means 19, to the next 18, 1 for the oldest data is 14. For forecast shipments in 12. And we can compare this data, the simple 3-year moving average forecast and the weighted moving average of the 12 years. This is what it looks like when we put its shipment and the year. This one represents the years, the x-axis, and the y-axis, the tons. And this line indicates the trend. So the data appears relatively linear, but not exactly linear, and fits a series of historical data points. The line fits, and the line fits the historical data, then it projects the line into the future. This line projects the future. The trend for a future looks like these lines. And B, the moving average forecast for 12 years would be that of moving average means when we want to forecast the 12 years, so we have to take the 11th, the 10th, and the 9th year. That is this one. We have to add this, and we have to divide to 3. And we can get 17. It will be 17. And when we calculate the 12 year using 3 weighted moving average, using weighted moving average, we have to give 3 for 19. We have to multiply by 3. We have to multiply 18 by 2. And we have to multiply 14 by 1. That means we are giving more emphasis on the recent data than the oldest data. So in this case, we get 17.8. By simply using moving average, we get 17, but by using weighted moving average, we get 17.8. This simple exponential smoothing, actually it is part of weighted moving average, and the weightage given for the past data, that means the name indicators, the name exponential smoothing indicators, the weightage given to the past data declines exponentially. So the weightage for the past data looks like this. It declines like exponential graph. Here is the formula for simple exponential smoothing. The new forecast represents ft equals the previous forecast ft minus 1 plus alpha, the smoothing constant. This smoothing constant can be determined first. It is between 0 and 1, and it can be determined first by the experts. And times demand of the previous period, that means the actual demands of the previous period minus the forecast of the previous period. Simply, actual demand of the previous period, the difference between the actual demand of the previous period and the forecast of the previous period is just an error. So the new forecast equals the previous forecast plus alpha times an error of the previous forecast, we can make the formula like this. We can multiply alpha with both dt minus 1 and ft minus 1, and we can make a film uses simple exponential smoothing with alpha that is determined, that is 0.2 to forecast demand. The forecast for the week of September 1 was 400 units, whereas the actual demand turned out to be 450 units. Forecast the demand for the second week of September 8. In order to determine the second week of September 8, we have given data, that is, we have given data, the previous forecast. The previous forecast is 400. We replace 400. Alpha is given 0.2. And the previous actual demand is 450. This one is 450. And the previous forecast is 400. So we calculate as 400. We get 410. And B, assume that the actual demand during the week of September 8 turned out to be 460 units. Forecast the demand of the week starting from September 15 up to October 2nd week. That means around October 15. Let the subsequent demands as this value, given as this value. So just we can substitute with this formula. For example, for September 15 forecast, 410 is the forecast of the previous period, that is here, and we replace 410 plus alpha value remains the same. In the bracket, 460, the given actual demand, this one is actual demand, minus 410, the forecast, the previous forecast, and it becomes 420. And the same is true for the remaining. You can calculate the same, in similar manner. And the next method is causal method. By the way, causal method is the more powerful. It is considered more powerful than the time series method because time series method uses only historic values to forecast the variables, and many factors are ignored. Many factors are ignored, but in the causal method, many factors can be considered in causal analysis. For example, the sales of the product might be related to the firm's advertising budget. As the advertising increases, the sales may increase, and the reverse is also true. The price charged, as the price increases, the sales decreases, and the competitor's price, the promotional strategy, even the economy and the unemployment rate can also affect the sales of the product. This can be considered in the methods of causal methods. In the causal method, in this case, sales would be the dependent variable that depends on these variables, this mentioned variable, and other variables will be independent. That means it affects the dependent variable, that is the sales. Dependent variable is the variable which we have to forecast, variable to forecast, and independent variable is having a causal effect on the dependent variable. A regression equation is one way of expressing the nature of the relationship between the two variables in causal methods. In the causal method, regression equation is the one which we use to express the relationship between the dependent and the independent variable. It is capable of dealing with cross-sectional data and time series data. Multiple regression, by the way, there are different types of regression, simple regression, multiple regression. In simple regression, we have only one independent variables which can cause. In multiple regression, we have several. We have more than one independent variables. Simple regression, an example is y equals a plus b1 times x1, and x1 is an independent variable, and b1 is the coefficient of x1, and a is an intercept, y-intercept, when we make x1 0. In the case of multiple regression, we have to put more than one independent variables. Here, x1 and x2 are independent variables. And here, b1 is, by the way, slope. it shows the relation, how much of y varies with regard to the variation of x. Here is an example, by the way. A linear regression is expressed by a plus bx, and the formula to compute the constant of the models are given below. In order to calculate b, we have to use this formula. In order to calculate a, we have to use this formula, and this formula are expressed by this. Let us see this example. A firm believes that its annual profit depends on its expenditure for research. The information for the preceding 6 years is given below. Estimate the profit when the expenditure is 6 units. That means the 7th year. We have to estimate the 7th year. And the expenditure for the research is given as x value, and the annual profit, that is a dependent variable that will be estimated, is y. So using this formula, first we have to determine the value of a and b after we calculate the value of a and b. So we replace in the equations of y, in the regression equation, y equals a plus bx. So we can get 20. We can calculate x value, y value, xy value, x square value to substitute in this equation. And we can x bar means, by the way, the mean of x, mean of y. After we add the x, so we get 30. And when we divide by the numbers, that is 6 years, we get 5. X bar is 5, y bar is 30. So we can substitute here. And summation of xy is 1000. We can substitute here, and x square, summation of x square is here 200. X bar square means 5 square, 25. And n is 6. So we can calculate a equals 20 and b equals 2 by substituting this into this variable. So we can get y 20. That means here the annual profit for the 7th year is 20. The other measure for demand forecasting is elasticity. As we have defined before, elasticity of demand is defined as the change in demand with regard to the price. The change in demand with regard to the change in price. Elasticity can be defined as percentage change in quantity divided by percentage in change in price. And if we know that the elasticity of demand is known and the change in price is known, so we can estimate the change in quantity. We can estimate the change. And the last section is the demand estimation. By the way, demand estimation or empirical demand functions are demand equations derived from the actual market data. Using the previous methods, we can estimate the demand, or we can prepare the empirical demand function, which is a linear equation, or which may be a log linear equation, which can use to predict the demand. It is useful in market pricing and product decision. The linear equation can be expressed as quantity demanded equals the constant plus B times P plus C times M plus D times PR, and this P, M, and PR are the price of the goods or services. P is the price, M is the consumer income, and PR is the price of some related good. In general, these independent variables, are the factors that can cause the demand to vary, or the factors or the causes that can affect the dependent variables, that is quantity. And this is the log linear. Anyway, estimating the parameters of an empirical demand function can be accomplished using regression analysis, as we see in the previous discussion. This is all about today's discussion, and if you have question or comment, you can put it below. Thank you. Have a good time.